This is Ariel from Science Friday. I'm here to show you how to make and test your own heat shield. For this activity, you're going to need a few things. You're going to need a heat source, in this case a blow dryer. It's my favorite heat source because it's inside and I can use it whenever I want. But you can also use something like our sun on a hot day. I'm going to need something that melts easily. I've chosen ice cubes. And you're going to need an oven-safe baking dish, and this is really just to contain the mess. It just makes it easier for you to keep from like splattering melty stuff all over. And so if you don't have ice cubes or you don't want to use ice cubes, you can also use crayons. They melt really easily. You can also use chocolate chips or even marshmallows sometimes. You don't want to use something that takes a lot of energy to melt because it's going to make it hard for us to do this safely. You're also going to want building materials. Anything made out of aluminum foil, aluminum carryout trays, leftover pop cans, all of that works. If you're lucky enough to have received a package that had insulation on it, you can use that. You can use felt fabric. You might want something like cardboard to make it kind of shaped the right way. And you're going to build something that's going to protect your easily melted object from certain melting destruction. So you might be wondering, why are heat shields important, or what could I possibly want to do with heat shields, or maybe what does this have to do with space? Well, the answer is that certain places in our solar system get really hot, and that's largely because of our sun. So our sun puts out loads of heat, but also radiation and a whole bunch of other things like solar wind, and that all can really mess up things like the electronics aboard spacecraft. It can also cook things like astronauts. And so heat shielding is a really important way that we can manage the temperature inside spacecraft and make sure that those computers and occasionally those astronauts get home safely. And there really are three main ways that it works. One is reflection, so you can kind of reflect heat back at the source, in this case the sun. Another important thing that you can do is insulate, so things that are soft and keep us warm in winter, or things that keep your ice cream cool when you take it on a picnic, like a cooler. Those are usually insulating materials, things like foams, anything that holds air, so you can insulate against the heat. And then as sort of a last resort, or rather in situations where there's really a lot of extreme heat, a lot of systems use what are called heat sinks, or something that absorbs heat. That's the main gist. Reflection, insulation, absorption. Step one, we're going to test our arena and make sure that our melting objects actually can melt. I recommend putting a little paper towel in the bottom of your dish just to keep your melting object from slipping. Grab one of your melty things, in this case an ice cube, and then kind of decide for yourself what your melting protocol is going to be. And this is important that you do it the same each time, because we're going to have a few of these and we want to be able to test and compare them. So in this case, I'm going to say I'm going to put an ice cube on in a baking dish with a paper towel. The other thing we want to do that I forgot to mention is you probably want to time it to see how long it takes. Ready, set. I decided to go on a medium temperature. Medium. It might take a while. It's going to take a long time. Alright, so I'm going to call that done. And I now know how long it takes me to do this. It's probably at least a minute to melt it without any sort of protection on it. And that's good to know, because now we know kind of a baseline. The second part's a lot more fun, frankly. The second part, you're going to design and build a heat shield. You can build whatever you want. I'm actually just going to make like a little heat house. I'm also going to use some foil. I'm going to wrap it. Ooh, I'm going to add some of this insulation that I found too. I'm going to even use a little tape here. If it helps you, a lot of designers find that it's helpful to sketch out and plan their design in advance, given the materials they have. Go for it. An ice cube right underneath. And I'm going to see if I do it for the same amount of time, is it going to melt as much? I'm guessing no, because I think my design is awesome. Ready, set. Now you might just want to check in already and say, what's happening. You can actually feel your apparatus already. In that same amount of time, though, it hasn't really melted, which is pretty cool. So it seems to be working. The other thing I can notice is I can make some observations about my heat shield. It's hot on the top. It's really hot on the top, but actually, this part, kind of cold like an ice cube, which is pretty rad. Go ahead and try a lot of different designs, use a lot of different materials, ask questions as you go, and then see if you can improve your design. You might even want to test it in multiple different heating scenarios. So what works really well with a blow dryer might not work so well if we're putting it on, say, a hot piece of asphalt. That would be a bummer. My name is Ariel from Science Friday. Thanks for joining me. You can find more activities just like this on the CoBuild19 Facebook group. And be sure to upload your designs after you try them out. I can't wait to see them.